What could possibly force thousands of airplanes to stop flying at the same time? A hidden engine failure? A massive software bug? No, the warning came from space. NASA detected unusual activity near Earth's magnetic shield, and experts realized something serious. Powerful solar radiation could interfere with aircraft computers. Within days, nearly 6,000 planes were grounded. This wasn't science fiction. It was a real reminder that our planet is connected to the sun in ways most people never think about. Let's break down what happened and why it matters. Our sun is not just a bright ball of light in the sky. It constantly sends out streams of charged particles. Scientists call this the solar wind. On top of that, Earth is also hit by cosmic rays, high-energy particles that come from far outside our solar system. Most of the time, we never notice them. Earth has protection. Our planet is wrapped in an invisible magnetic field called the magnetosphere. It acts like a giant shield, pushing away most harmful particles. But sometimes the sun erupts. Solar flares and solar particle storms blast huge waves of radiation into space. When those particles reach Earth, they can disturb our magnetic field. These storms are also what create beautiful auroras near the North and South poles. The glowing lights may look peaceful, but the energy behind them can be powerful. During a recent period of solar activity, engineers became worried about something very specific: aircraft computers. Airbus discovered that around 6,000 of its A320 family aircraft might be vulnerable to radiation-related glitches. About 5,000 of those planes needed urgent software updates. Around 900 older aircraft required complete computer replacements. Why? Because when airplanes fly high in the sky, the air becomes thinner. Thin air means less natural protection from space radiation. High-energy particles can travel deeper into the atmosphere. Inside every modern aircraft are microchips, tiny pieces of hardware that process data every second. These chips use binary code, which means everything is stored as ones and zeros. If a high-energy particle strikes a chip at just the wrong moment, it can flip a bit. A zero becomes a one becomes a zero. That tiny change is called a single event upset. It sounds small, but it can create serious problems. In this case, engineers were concerned about software that calculates the aircraft's altitude. If the data becomes corrupted, even briefly, the plane's systems could respond incorrectly. Now imagine this happening mid-flight. Concerns grew after a serious incident involving a JetBlue flight traveling from Cancun to New Jersey. During the flight, something went wrong. The aircraft suddenly dropped sharply. The movement was so fast that passengers were lifted from their seats. Some struck the ceiling. Around 15 to 20 people were later taken to hospitals. At 2:19 p.m., the pilots made an emergency landing in Tampa. Medical teams boarded immediately. The aircraft was removed from service, and investigators began looking into possible causes. Among the possibilities, solar activity interfering with flight systems. While investigations continue, the timing raised serious questions. Airbus responded quickly. Software patches were rolled out faster than expected. Airlines worked around the clock to update affected aircraft. Within days, most planes were cleared to return to service. But the event raised a much bigger issue. How safe are we from space weather? NASA has been studying Earth's magnetic shield for years. 4 small spacecraft known as the Magnetospheric Multiscale Mission, or MMS, orbit along the edge of our planet's magnetic field. Their job is to watch how the magnetosphere reacts to solar wind. During one pass, the MMS spacecraft recorded something unusual: a twisting bend in Earth's magnetic field. Scientists call this structure a switchback. Switchbacks have been seen closer to the sun before, but spotting one near Earth was unexpected. It suggested that magnetic energy was behaving in a more complex way than previously thought. This twist occurred in a region called the magnetosheet, a turbulent zone where solar wind crashes into Earth's magnetic shield. Inside the switchback, the spacecraft detected fast-moving electrons mixed with solar particles. The cause appears to be magnetic reconnection. That's when magnetic fields from the sun and Earth snap together, then suddenly release energy. It's like stretching a rubber band until it snaps. When this happens, bursts of energy shoot through space. Small reconnection events create auroras. Bigger ones can disturb satellites, radio signals, GPS systems, and even power grids. The concern is that certain magnetic disturbances might allow radiation to penetrate deeper into our atmosphere than usual. If that happens during a strong solar storm, the impact on technology could be serious. This isn't just theory. Scientists recently uncovered evidence of an ancient megasolar storm buried in tree rings. Researchers studying old wood discovered a massive spike in radiocarbon levels dating back to around 12,350 BCE, near the end of the last ice age. Radiocarbon forms when cosmic rays interact with Earth's atmosphere. Trees absorb this carbon and lock it into their rings, creating a natural timeline. The spike was enormous. Using new climate chemistry models, scientists determined that this ancient solar particle event was far stronger than the famous storm of AD 775, previously thought to be the most powerful ever recorded. Compared to a strong storm in 2005, the ancient event was hundreds of times more intense. Even the Carrington event of 1859, which knocked out telegraph systems around the world, was a different type of solar eruption and may not have matched the intensity of this ancient particle storm. These extreme events are rare, but they do happen. And today, our world depends heavily on electronics. Satellites guide airplanes, GPS directs ships and trucks. Power grids supply electricity to billions of homes. Communication systems connect entire countries. A solar particle storm on the scale of the ancient event could overload satellites, disrupt navigation, and damage electrical infrastructure. The grounding of 6,000 aircraft may have been a precaution, but it showed how seriously the aviation industry now takes space weather. In the past, pilots worried mostly about storms in the clouds, and now they also have to think about storms on the sun. Luckily, we are entering a calmer phase of the sun's 11-year activity cycle. Solar maximum, the period of highest activity, is slowly declining, but the sun never truly goes quiet. Even during calm periods, it continues sending charged particles toward Earth non-stop. That is why space agencies monitor the sun 24 hours a day. Satellites constantly track solar flares and coronal mass ejections. When a large burst is detected, alerts are sent out to airlines, power companies, and satellite operators. Preparation is key. Airbus's rapid response likely prevented further incidents. Updating software to better handle single-event upsets can protect flight systems from radiation-related errors. Newer aircraft are also being built with stronger shielding and improved error correction systems. Technology is adapting, but the recent magnetic switchback detection reminds scientists that our understanding of Earth's shield is still growing. Each new discovery helps researchers predict which solar storms might be dangerous and which ones are harmless. The idea of a magnetic shield breach might sound dramatic. In reality, Earth's magnetosphere constantly flexes and shifts under pressure from the sun. Small cracks can open and close as magnetic energy flows. Most of the time, these changes are manageable. However, extreme events, like the ancient megastorm recorded in tree rings, show that our star is capable of far more power than we experience in normal lifetimes. So what does this all mean? It means our planet is not isolated. We live inside a space environment shaped by a dynamic star. When the sun acts up, we feel the effects, sometimes in surprising ways. The grounding of thousands of aircraft was not caused by panic. It was caused by caution. Engineers recognized a vulnerability and acted quickly. In a world that depends on precision, even a flipped bit inside a microchip can matter. The good news is that science is improving. Monitoring systems are better than ever. Aircraft software is becoming more resilient. Space weather forecasting is advancing. We cannot control the sun, but we can prepare for it. The next time you see the northern lights glowing in the sky, remember, behind that beauty is raw energy powerful enough to shake satellites and worry engineers. And the fact that we detected the risk before something worse happened shows how far technology has come. If you found this story fascinating and learned something new, make sure to like this video and subscribe for more deep dives into science, space, and the hidden forces shaping our world. See you in the next one.